We know that SCADA stands for Supervisory Control and Data Acquisition. Yeah, as the name itself indicates, we can perform many tasks here. It contains two things. One is supervisory control and data acquisition, right? As a part of this, it collects data from remote sensors and instruments. In industrial automation or any automated process, we will have many sensor and actuators and other instruments like HMI. We need to collect data from all the sensors to know whether they are working or not. That is done by SCADA. That is, it collects the data from remote sensors and instruments which are placed across my plant or across my automation industry, which is distributed across maybe acres of land. Yeah, and it displays it at central location for monitoring. We will be using a computer where we can sit in front of that and we can monitor all the data from the sensors. Apart from that, we can also transmit some control signals for controlling the automated process. In the field, we will be using many actuators. We can turn on and turn off the actuator through the computer screen where we are sitting in front of that. That is what SCADA is. SCADA stands for Supervisory Control and Data Acquisition. It acquires the data from the field devices, and also we can monitor, that is, we can supervise, and we can also control the process that is happening across the industry. So we will be knowing the theory part. So I am going to cover the practical part more so that you will be understanding the things better. We have used a software from Delta, that is DIA Weave development software, where we have developed the SCADA screen. I'm going to open that. So it has got numerous applications in the industries. Sitting in front of the computer, we can monitor the automated process that is happening across acres of automation land. So this is the software. First, I am going to demonstrate how effectively we can use the SCADA screen for automation process.
ಏನಾದ್ರು ಕಾಣುತ್ತಾ ನಿಮಗೆ ನಾನು ಮಾಡೋದಕ್ಕೆ ನೀನು ಮಾಡೋದು ಅದಕ್ಕೆ ಹೇಳಿದ್ದವ ಅದು ಮಾಡಿಸ್ಕೊಂತೀರಾ ಅಥವಾ ಅಲ್ಲಿ ಹೇಳಪ್ಪ ಮಾಡ್ಕೊಡ್ತಾರೆ ನೀಟಾಗಿ ಅಂತ ಹೇಳಿ ನೋಡು.
Yeah. See, this is already created. I'll just run it.
ನೋಡು ಓದಕ್ಕೆ ಯಾವ ಚೆನ್ನಾಗಂದು ನೀವೇ ನೋಡ್ಕೊ ಗೊತ್ತಾಗುತ್ತೆ. ಬೇಡ ನೋಡ್ಕೊಂಡು ಹೇಳ್ತೀವಿ.
I'll have to ignore some warnings. I am going to demonstrate one real-time applications of SCADA. This is the demo project shown by this application itself. This is not created by us, in fact. So it takes some time to run the automated process. Yeah, this is what, how effectively, how interactively we can animate the automation process. We know that the things will be more interesting if we animate the things that are happening in the industry. You can see some pipeline system over here. Here, this is water heating system. the water from the storage tanks go through the heating system, get heated, and will be distributed to the other pipes. We will be using some pumps in between. We will be using some pumps in between. This status and all can be known sitting in front of the computer itself. See, and other parameters. What we will be putting some sensors to know whether all the field devices like pumps and sensors and heating system are working or not. These alarms can be programmed to appear on our screen. This is everything on the screen is programmed to get the real-time status of the field devices that we have installed around 1 kilometer and more. We know that water distribution system may long for more than 1 kilometer or 2 kilometers. This data from the field devices can be monitored sitting in front of the computer. We can see the working of heating system. We can see the pumping of water in each pipe, right? And we can see the water level in the each tank, and we can see the temperature, that is temperature of the water passing through the each pipe. This is how we can program the SCADA screen to get the real-time data from the field devices. Yeah, this is the demo project given by this SCADA software. Now, as a part of our syllabus, we have developed the SCADA screen for one real-time application that I can show here. I hope the things are being understood. We have developed, and our students have developed so many SCADA screens.
Internet connection is unstable.
Some voice I am able to hear. It may disturb other students, so kindly mute your mic. Yeah, I hope the SCADA screen is visible. This is what we have developed for a simple application, that is water level controller, right? We can develop the such screen for another applications as well, like metal counting and all. Now I can show you the physical setup here. This is the overhead tank. This we have used as a sump. We have used one sensor. We have used one sensor in the sump to see whether the water is available in the sump or not. You can see two wires over there, and we have used three wires. We have used three wires in the tank, and in that two wires will be acting as sensors. So one red color wire will be acting as low level sensor, and this green level wire will be acting as high level sensor. That's all. Just we have used some wires or sensors in this particular application. The same things are being used in water level automation in houses as well. This is the PLC and other connections, right? Now the motor is off. That can be seen here. You can see on the monitor screen, that is motor status. The motor is off. And since there is no water, the door open. Some lighting issue is there. I am just ensuring it can. Yeah, since there is no water in the tank and no water is reaching both the low level sensor and high level sensor, same thing can be seen on the SCADA screen. See, TLLS is red, indicating that no water touching tank low level sensor, and THLS, tank high level sensor, is red, indicating that there is no water touching tank high level sensor. According to our logic, the sump has to turn on now because there is no water in the tank. Our sump has to turn on. I have used two master control over here. One is start, another is stop. Without starting my automation system, even though there is no water in the tank, my system, my motor will not get turned on. I've already told you I can perform some supervisory controls through the SCADA screen. Now I will show you. I am going to turn on this automated system using by pressing start button. You can see I am pressing the start button, and now after that these sensors will be read, and according to this sensor the automated system will decide whether to turn on this motor or not. I will press the start button. Now we can see the motor gets turned on. You can see the motor has turned on. The same indication I have animated in the SCADA screen. You see the motor has turned on. I have written little bit program for this tank as well. When the water reaches above the tank low level sensor, now you see the water in the tank I have shown to be 50%. For this I have to write little bit program apart from the SCADA screen. Now you see the water is getting filled, and this tank low level sensor has turned on, indicating that there is a water just above the tank low level sensor. Now we can see the water has not yet reached this tank low level sensor, tank high level sensor. So it is red. At any time in unavoidable conditions, I can turn off this automating system through the SCADA screen only. Now I can turn it off by pressing the stop button. See, I just pressed the stop button, so the motor unconditionally has stopped working. Until unless I press start button, the automation system will not work, even though the sensor shows various data where I have to turn on the motor. Now I am going to drain the water. When the water goes below the low level sensor, this is going to be turned off. It means it becomes red, and the water and the will be shown below 20%. This we have done for simple application, thinking cognitive level of our students. Now we can see the water is getting drained. Since still it is touching the low level sensor, the data from tank low level sensor is still there. As soon as the water goes below the low level sensor, this becomes red. That's what, by sitting in front of the computer, we can monitor all the field devices that we have used in our automation industry. Otherwise, this tank low level sensor has become turned on. Even though the data, there is no water in the tank,
font size sab ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಇದು.
The motor is not turning on because I pressed the start button. I just stopped the entire automation process. Until unless I press start button again, this is not going to start my automation process. So I will stop draining the water. Again, I'm going to press the start button. See, when I press start button, according to the sensor, this will work. Anytime I can press stop button to ensure the automation system to stop. Again, see, there is no water. There is no water in the tank. Still, the motor is not turning on because I turned off the automation system. That is what we can have some controls from the SCADA screen. We can have the indicators of the field devices on the SCADA screen. So now I have used one sensor in the sump. I will just lift the wire from the sump. Now you can see on the SCADA screen, the SLS will become red, and the sump as shown, it has got water below some particular level.
status start to stop
Now you
lower
see,
sensor, sump sensor, motor status.
I'll keep the sensor inside. The water is shown full of sump. Now I'll again lift the sensor from the sump. Again, the water is shown nil in the sump. So that's what the real-time data can be monitored, and also the automated system can be controlled. Again, I'm going to turn on the system based on the sensors. It will bring up the water. So now I will assume that there will not be water in the sump. If there is no water in the sump, there is no water in the sump. So the motor has to turn off. That is what automated system is. So when there is a water, again it will be. I think this is a simple application.
ಅತಿಗೆ ಕೂಡ ಒಂದೇ ಸಲ
That
ಎಲ್ಲ
can be
ಅಗ್ಲಲ್ಲಿ
easily understood
ಇನ್ನೇ
by
ಇಟ್ಕೊಂಡು
each and every student, because nowadays this particular automated system is common in every houses. Now I will be showing the full filling of this water tank. I mean overhead tank. When will be the motor turned off? When the water reaches above the upper level sensor, that is high level sensor, the motor will turn off automatically. Now you keep an eye on tank high level sensor, and this real time sensor I have used in the field. That is here. If other people can mute your mic, my screen will be visible on their screens. Kindly mute your mic. You see the water is filling. It takes some time to fill the water. We have AC motor for that purpose in the sump, submersible pump. Meanwhile, we can go through the PLC connections. That is X0 and X1. X0 and X1 are used for starting and stopping. Even I can have some manual controls as well. By pressing this, I can start the automation process. Apart from SCADA controls, by pressing this, I can stop my automated process. And X2 is connected to tank low level sensor placed in the tank. And this X3 is connected to tank high level sensor. This X4 is connected to sump level sensor. So this is the physical connections we have made. Water is about to touch my high level sensor. Now this will turn green and this will turn red. It means it goes off. Yeah, it's going to touch. You see, this became red, this became green, and this became off. And according to our syllabus, there is one more question. We need to monitor this reservoir system. We need to monitor reservoir system, and also we must be able to explain how it works. They may ask how this reservoir system can be controlled and monitored through this SCADA screen. We will be using solenoid values there to open the gates and to close the gates. In such cases, the water level from the dam can be seen on the screen. At various levels, we will be keeping the sensors that can be seen here, and based on that water level sensor, we may need to open some gates in the dams. we can see if there is a sensor, there is a data from that sensor, particular gate has to be opened in the sense we will monitor whether that gate will be opened according to the sensor or not. Because we cannot go to the dam when it rains. We need to control from the distance location only. Do anybody has questions on this? Like how we have interfaced, and from the practical aspect, we don't need to connect any extra cables between PLC and this computer. You know that SCADA is nothing but a screen on the computer. It's just an application like Microsoft Word. We have to create all these screens from the applications, right? Just we have used one serial cable for connecting. Just we have used one serial cable between PC and PLC. Even though we have used a serial cable, but it uses some other protocol called Modbus that can be seen while developing the SCADA screen. Likewise, they may ask, explain the different protocols that can be used in dam shutter control system. Dam shutter control system, we can explain this Modbus, right? We may get some 5 marks over there. That's what, starting from electronic projects like automation, even in civil engineering also, we can use such products. I can show you, this is the screen. This screen we have developed, right? I can show you that window. This is the screen we have developed. This is the screen we have developed. These all objects I only have created like this. See, I will show you how to create this object. One object I will show you. I'll go to gallery, then I'll go to some indicating instruments. I'll take one. I'll click on this diode 3, then I'll drag on my screen. See, this button has come. When after this button has come, I have to link it to real-time variables from the PLC. We know that we have used Delta DVP 14SS2, which has got 8 inputs and 8 outputs. That I can link here. See, whatever the status is happening from this real time, that has to be appear on my screen. Now I will just link to one of my variable, that is output, motor status again. Let me show you how to link this variable to my output. I'll have to click this, then go to animation, then click on this child animation, then you click on 3 dots. Now I will have to link to my variable. So these are the variables I have taken. I'll just take motor. Now see, when motor turns on, it has to turn green. When motor is off, it has to turn red. So this is how I link these buttons with the real-time I/O ports of my PLC. See, I just linked it. Now let us see if it works according to my PLC status or not. So it means I am about to say that all the screen parameters or switches are available, are created by us. You see, this motor status is off, and now this is red. Whenever motor turns on, this turns on, it becomes green. That's how all these switches and indicators are linked to the real-time physical I/O ports of this PLC. Right? This is the controller. PLC is the controller. So this is what the working of water level controller. Now I can show you how these are physically connected. somebody has scratched on the screen. I'm sorry, I'm helpless. Yeah, see, this is how connected. I have used one controller there, PLC. This is programmable logical controller, which we can program to do any task, right? We have, as I said, we have used two push buttons from the PLC as well, X0 and X1. I can turn on and turn off from the PLC end as well. And tank low level sensor, high level sensor, and sump level sensors are connected to X2, X3, and X4 respectively. And only one output I have taken from the PLC, which is connected to the motor through the relay, right? So turning on and off of this output will turn on and off of relay, in turn which will turn on this motor. So as I said, SCADA is nothing but a computer screen, one application in the computer. This is the screen we have developed, and between PC and PLC, I have used a Modbus serial cable. Of course, it is a serial cable, but underlying protocol is Modbus. Since the cable connections are same, I have used only 3 wires. I mean, serial cable uses 3 wires only in this cable. We know that, but still, even though it is serial cable, underlying protocol is Modbus. This we have to select while programming my SCADA screen. And this is my PLC program, which I have dumped into my PLC. We have used 2 push buttons, as I said, from the PLC end. One is X0 and X1. This is simple DOL starter. Press X0 to start the automated process. Press X1 to stop the automated process. As I said, we need 2 controls from the SCADA screen that I have linked to memories of this PLC, M0 and M1. Whatever the action is performed by X0, same action is performed by the M0. That is, we know that this is like OR gate, this is like AND gate, right? Pressing either X0 or M0 will turn on this M2. Pressing X1 or M1 will turn off M2. That is why this M2 is used as a master control to turn and off of this automated process. And these X2 and X3 are connected to tank low level sensor and high level sensor, whereas X4 is connected to sump level sensor. This is my simple PLC program of water level controller. I have added only 2 parameters, that is M0 and M1, to make it as a SCADA program. Otherwise, it is a simple water level controller. This is I have linked in the SCADA screen that I can show you. Let us go to this again. Now I will show you the start and stop are linked to M0. You double click it, sorry, you click on the start and go to this animation. Not there. Now we will see here in this. IO device. Here you can see the start is linked to memory M0. Stop is linked to memory M1. These are start and stop from the SCADA screen. So that's how. And Y0 is linked to, the motor is linked to Y0. So we need only 2 extra variables to have control from the SCADA screen. That's how the SCADA can be used for real-time monitoring and also controlling the automated process. Let us go through the applications of the SCADA. The SCADA systems are used to regulate and monitor physical processes. For example, electricity distribution. We can, even in the field of electricity distribution, we can see the amount of power level there and amount of heat that is present in the distribution system. And also we can use the same thing in gas and oil transit pipelines. We will see whether there is any leakage in the gas and oil transit system. That also can be found using sensors, we know that. And we said it is used in water distribution system. Even we can see we can use it in the traffic lights, right? A person sitting in front of the computer can alter the traffic timings depending on the traffic in any site, and other systems that serve as foundation of modern society. Right? This is what I have planned for. Are there any questions? Is my question clear? I mean, is my session clear and helpful? Or any doubts I can show on the screen?
No, sir. Please carry on.
No, I'm going to wind up this session. I think I'm done with it. If any doubts are there for students or any other stuff, I can tell if I know. I mean, if I get to know. Yeah. Shall I wind up? I thank all the staff uh, for arranging such a session to students. I hope this session is useful and got some knowledge among the students. Thank you. Thank you, everybody.
Thank you. Thank you, Naveen, sir.
Welcome, sir. All the best for the students.